Sixth grade lesson 2.3 is comparing and ordering fractions and decimals. This is, again, one of those concepts that have a lot of you guys nervous, the fractions and decimals, just because you're not as comfortable using them as you are using a whole number. But that's because you've worked with whole numbers for so much longer than you've worked with fractions and decimals. So be patient with it. It will click into place. And hopefully by the end of this year, you're feeling much more confident with it. And then when you see it again next year, you have less nervousness and anxiety about fractions and decimals. So to compare them, when they want us to compare and order numbers, they're really looking for which one's bigger than the other, which is least, which is greatest, order them from least to greatest or greatest to least or whatever. So with fractions, in order to compare fractions, usually what you need is the common denominator, because that's showing that they're cut into the same amount of pieces. Whatever it is cut into the same amount of pieces. There is one twist to that I'll show you in just a moment. But this is saying 2/3 compares to how with 1/3. So I put a third over here, candy bar split into thirds over here, and a candy bar split into thirds over here. And as soon as I say candy bar, you're probably like, yeah, 2/3 are better than 1/3, Miss Sanchez, because I get to get two parts of it more than the one. So here's 2 out of the 3, and here's 1 out of the 3. And so, yeah, you were right. 2/3 is more than 1/3. It's easy to just compare those numerators if your denominators are the same. So that's more. If I cut a candy bar into 3 equal pieces and you got to eat 2 of them, but your brother only got to eat 1 of them, you got more. So that one seems pretty easy. Sometimes, if the denominators are different, but the numerators are the same, you can compare those. And here's what I mean by that. Here I have 2/3, and here I have 2/5. These denominators are not the same, so generally when I see that, I think, oh, I can't compare them until I get a same denominator. However, my numerators are the same. And if you reason out what this chopped up means, you can start to reason out which size pieces are bigger. So let's say I had a candy bar that I cut into 3 equal pieces, and I had the same size candy bar, but this time I cut into 5 equal pieces. These pieces are going to be smaller, aren't they? The more you cut it up, the smaller it gets. So if you can keep that in mind, then we're looking at 2 pieces that are a little bit bigger than 2 smaller pieces. And here it is drawn out. I have 2 out of 3. So it's cut into 3 even pieces because that's what the denominator says. 1, 2, 3 even pieces, and I get to eat 2 of those pieces. If my brother gets to also have 2 pieces, but the candy bar that he's getting 2 pieces of is cut into 5 equal pieces, he's getting 2 smaller pieces. So that's a good trick to play on your brother. Okay? So if your numerators are the same, and you know that the more times you're cutting up something, the bigger that denominator gets, the smaller the pieces get, then you can kind of reason out which one's bigger than which. So in this case, 2/3 is bigger than 2/5 because they're cut into bigger pieces than the 2/5 are. All right, so what if they're not the same numerator or same denominator? What do I do then? Well, remember, you have control over cutting these up the way you need to so that they can be cut the same way. And the skills we use for that are LCM to get that lowest common denominator. So if I counted by 3 and counted by 8, or just multiplied them by each other, doesn't matter if it's the lowest one, we could just use a common denominator. So let's say we wanted to do 3 times 8 to get 24. Now they're cut into the same amount of pieces. Now, I can only do a times 8 on this if I cut this up the same way. You have to be fair to the whole fraction. So if I'm deciding I'm just going to multiply this by 8, then you have to also do the same to the numerator. Here's why. Let me explain it better. So if I have this pizza and I cut it into 1/2, there's 2 equal pieces, right? And I get to eat one of those 2 gigantic pieces. if I cut that, if I said, oh, I'm just going to multiply that denominator by 2, and now I have 4 equal pieces. 1, 2, 3, 4. I still got to eat that 1/2, right? But now that I've cut it into 4 equal pieces, that's 2 out of 4. They're equivalent fractions. We have to keep those fractions equivalent, even though we're manipulating them to be the numbers we want. That's why I have to, if I'm going to cut this 8 more times, I need to do that same to the numerator. So 2 times 8 gives me 16. Then I have this 24. It was an 8. I multiplied it by 3 to get to 24. And if I did that to the denominator, I must do that to the numerator as well to keep it equivalent. And now that my numerators are the same, I can look at my, back up. Now that my denominators are the same, I look at my numerators to see which one's bigger. 16 is more than 15. Done. Okay, so let's say they're asking us to order these numbers from least to greatest. I have 6 1/2, 5 2/3, and 5 5/8. I really only need well, really, I'm going to start by saying, well, okay, which is the largest number? I'm going to look at their whole numbers first. Because remember, the fractions are just the in-betweens of that and the next number. So I have 6, and then I have 5, and then I have 5. So 6 and a little more, 5 and a little more, and 5 and a little more. So of those, without even doing any calculations, I already know that this 6 and a little more is more than either of these. So I'm going to put this way over here in my the greatest. It's the most. It's 6 and more money, $6 and change. And that's going to be bigger than $5 and change and $5 and change. Now I just need to know between these two, which one is larger. So I'm not looking at their whole number. That's not going to change. I'm just looking at their fraction amount. So we are comparing 2/3 and 5/8. Look familiar? We just did this one, right? We did, just to get a common denominator, we did the 3 times the 8, the denominators times each other, and got 24. And remember, we had to be fair. If I did 3 times 8 here, I had to do the same to the denominator. 2 times 8 was 16. And if I did 8 times 3 to get 24 here, I had to do 5 times 3 to get 15 here. They are equivalent. And so now I know that 2/3 is more than 5/8. So this is more, and this is the least. So I'm just going to go ahead and fill that in. 5/8 is the least, and 2/3 is the next amount when 6 was the biggest one. Let's look at another example, because you're probably feeling like you could have used another explanation there. We want to order these numbers from least to greatest. Always look for that too, because sometimes they reverse it on us and want greatest to least, and I mess that up when it happens to me. So this time they want least to greatest. I always double check. I have 3 and a little bit more, 3 and a little bit more, and 2 and a little bit more. So, okay, right away, I know that 2 and a little bit more is less than 3 and a little bit more and 3 and a little bit more. So that one I'm not even going to have to worry about calculating. That's going to be my lowest amount. So then I know that 3 and a little bit more and 3 and a little bit more are going to go here. I just don't know which little bit more, because I can't tell just by looking at it right now which is more and which is less, because they're cut differently. So I'm going to give some focus to those two fractions, 3/6 and 5/8, to see which one is bigger and which one is smaller. Okay. I'll just, for me, because that number is going to be very, very big, I think I'm just going to go to LCM and find the LCM between these two numbers, 6, 12, 18, 24, and 8, 16, 24. That's can be a common denominator. That will be the lowest common denominator between those two, is that LCM that they both meet at. All right. In order to get 6 to become 24, I have to multiply it by 4, right? So I'm going to multiply by 4 to the denominator, which I did, and now to the numerator also. Same with this, from 8 to 24, it's going to be times 3. 1, 2, 3 times, so I will times 3 there. And if I did that to the denominator, I must be fair and do the same thing to the numerator to keep it equivalent. Now that they are cut in the same way, I can compare their numerators. 15 is bigger than 12, so that one's more. And I lined them up nicely on my paper because I didn't want to forget which is which. So 5/8 is bigger than 3/6. So I'm going to go ahead and put 5/8 as the bigger one and 3/6 as the smaller one. So least to greatest, 2 9/10, 3 3/6, 3 5/8. Okay, and before we go on to the next part, I'm just going to do a quick reminder of how do I change the decimal to a fraction, because we're going to go into the part where now we're comparing decimals and fractions with one another. So if I wanted to make the decimal a fraction, this is, I take the number that's to the right of the decimal and I make that my numerator. The denominator is the place value that the number ends in. It ends in the tenths place. And then I just reduce that fraction. That can be divided by 2 to both the numerator and denominator. 2 goes into both of those evenly, and I get 3/5. So 0.6 is the same as 3/5. So there's your refresher on that. So now one of the things you're going to see is you will see them ask you questions like, well, which one's bigger and which one's smaller? 0.92 or 1/2? Well, so you have a couple of choices. You can decide, I'm going to convert this to a fraction and compare them and get a common denominator and compare them. Or you might decide, I'd rather change this fraction into a decimal and then compare them. Especially if you remembered from the last lesson what 1/2 is as a decimal. Now you've got it easy, right? I'm going to show you both ways of doing that, but you, of course, would only choose one. So if I wanted to do 0.92 and 1/2 compared, and I decided I wanted to turn this guy into a fraction, it's going to be 92 over 100, because it ends in the 100ths place, being compared to 1/2. Okay. Then I need a common denominator, and for me it's easiest to get this to become 100. I can do 2 times 50 to get to 100. So I'll do times 50. As long as I do the same to the numerator, I'm good, right? So 92 over 100 compared to 50 over 100. That's still 1/2, just written differently. Instead of cutting the pizza into 2 equal pieces and eating one big piece, I have cut that pizza into 100 tiny pieces. I get to eat 50 of them, half of them, right? That's half. Okay. But now that my denominators are the same, I can just compare my numerators. That's 92, that's bigger than 50, so there's my comparison. The alligator goes to the bigger number. What if I was somebody who said, I'd rather just change them both to decimals? All right, no problem. So to remember to change to a decimal, you just do the division. This is a number over a number. It's a division problem. We're going to do 1 divided by 2, unless, of course, you've memorized that one already. 2 does not go into 1. We knew that already. If it's a proper fraction, it's not going in. Decimal, 0. 2 goes into 10 5 times. Oh, how about that? 0.5 compared to 0.92. You can put the 0.50 if you want those to match here. You can put a 0 there if you want it to match. But we're looking at 9 dimes, 9 in the 10ths place compared to 5 dimes, 5 in the 10ths place. So this one is bigger than that one. You're still getting the same answer regardless of which way you do it, as long as you're using the right skills. Let's look at another example. We're looking at 0.8 being compared to 3/4. Which one's bigger? So again, you would only choose one way. You would choose, I'm going to go ahead and convert this to a fraction and compare them. And somebody else might say, nah, I'd rather change that to a decimal and compare them, especially if you have memorized what 3/4 is a decimal. You might have by now from the previous lesson. I'm going to do it both ways so that you can see it both ways, but you only need to choose one way. So if I wanted to change 0.8 into a fraction and then compare it, it would be 8 as the numerator, and it ends in the 10ths place, so that's my denominator. I would reduce that because they're both divisible by 2. That's going to give me 4/5. I'm comparing that to 3/4 over here. I need a common denominator. I'll just go ahead and do 5 times 4 to get 20, because if that's a factor of 20 and that's a factor of 20, then both of them divide evenly into 20, right? So I know that that's going to be a common denominator they share. It may not be the lowest one, but I think it is the lowest one, but it doesn't have to be the lowest one. All right, so how did I get from 5 to 20? I multiplied by 4. Do the same to his numerator best friend. So 4 times 4 is 16. How did I get from 4 to 20? I multiplied by 5. Do the same to his numerator best friend. 3 times 5 is 15. So now I just compare my denominators are the same, so now I just compare my numerators. 16 is bigger than 15. Ta-da. Alligator goes for that. If you are somebody who says, I just like dealing with decimals, I don't like fractions very much, I'd rather just deal with the decimal. And if you don't remember that what 3/4 is as a decimal, no problem, do the division. This is 3 divided by 4, and of course it's a proper fraction, so we already know it's not going to go. We needed it to be 0 point something. Then we add the 0. 4 goes into 37 times, because 7 times 4 is 28. With 2 left over, bring a 0 down. 4 goes into 25 times, exactly, with no left over. So 3/4 as a decimal is 0.75. And now I'm looking at this, that's 8 dimes, and that's 7 dimes and 5 pennies. 8 dimes is more than 7 dimes, right? So that's bigger by 5 cents. So that's how you handle those. You have to just decide which one you want to convert to the other, and you choose what's more comfortable for you. You convert it, and then you compare it. So the book also shows you that another way to do it is to use a number line, and if you're comfortable with using the number line and how fractions and decimals appear there, this could be a useful tool for you. For me, I prefer just converting one to the other, but I'm going to show you this because my brain may not work like yours. Maybe this makes much more sense to you. But let's point out a couple things about the number line just to make sure that you understand how that is split up. So I have zoomed a number line way in to just between 0 and 1. So 2 would be way off this way, 3 would be way off this way. I have zoomed in, and now I'm just looking at the in-between of 0 and 1. And decimals, remember, are in tenths and hundredths and thousands. That's how many pieces you're splitting up between one whole number. So these are my tenths places. So there's 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and then if I have all 10 of the tenths, of course I have one whole. Written in fraction form, same amount, 1/10, 2/10, 3/10, 4/10, because I've split everything into 10 equal pieces from 0 to 1. So if you recognize that that's all that is, I can look at these numbers here and kind of figure out where they're at. This is 9/10 and a little bit more. So it's way up here, 9/10 and a little more, half more, right? So it's going to fall somewhere in here, right? About between the middle of 9/10 and 10/10. So I'm going to put it way up here. 0.95 is going to live right there, just past the 0.9. 3/10 lives right here. And 1/4, I don't have this broken into fourths. I have it broken into tenths. But I can go ahead and turn it into the decimal, 1 divided by 4, if I don't have that memorized already. 4 into 10 goes in twice. You get 8, 2 left over. And 4 goes into 25 times. And that is 0.25. 1/4 is the same as 0.25. You knew that, right? Because 25 cents is 1/4. So on the number line, I'm going to the 2/10, and then it's in between. It's 5 pennies, so it's 2 dimes, 5 pennies, right in between, right? So right there is 1/4. And now on the number line, I have 1/4 is the least, 3/10 is the next least, and then 0.95 is the largest. Don't worry if these are feeling hazy to you. The practice is what's going to make it sink in. So the more we practice it, the more comfortable you become with these numbers, and then you're an expert at it before you know it.